Hi, my name is Massimo Refere. I'm a principal technologist at AWS in the container service team. In this session, we're going to talk about the options that you have when you deploy your containers on AWS. In particular, we're going to explore the concept of the data plane that you can use and the options that you can use on the data plane. What we're going to cover here is basically trying to make sense of a lot of technology names and a lot of services that you may have heard in the last few months or even years. In this period, you may have heard about things like Fargate, Linux, BottleRocket, Outpost, Windows and Linux, ARM CPUs. How does this all relate to container? We're going to find out in this presentation. And in particular, what we're going to do is we're going to describe at a high level what these things are, what you may need for your business, and what works with what. The goal for the next 29 minutes is two things. So first of all, what this presentation is not. This presentation is not a vehicle to introduce new features, new services that we launch at reInvent. The other thing that this presentation is not is a deep dive into any of those technologies. What this presentation is intended to be is to challenge some of your assumptions in terms of what you need to run containers on AWS. So we want to give you an understanding of the richness of the data plane, and we want to give you elements to be inspired about things that you may to look at to go beyond what you're using today to deploy your containers on AWS specifically. We also want to give you some motivation to go deeper into some of the topics that we will discuss during this presentation. I will provide some links at the end of this presentation where you can go a little bit deeper into the topics that we will be discussing. So I kept talking about this notion of the data plane. Let's put some guardrails in terms of the naming convention that we're going to use for this presentation. Whenever we talk about containers and deploying containers on the cloud, we're talking about two big buckets or elements or technologies, so to speak. We're talking about the control plane and we're talking about the data plane. In real life, our day-by-day real life, a good example of this would be the director of an orchestra and the orchestra itself. The director or the conductor is the person that knows how to make things move. The orchestra is where the music gets generated. In our case, if we go back to containers, the parallel here is that if you as a user need to deploy a container, you're probably going to talk to an orchestrator, which implements the control plane. The orchestrator will be able to find the resources on the data plane to start your container. These resources may be CPU, memory, network connectivity, GPUs, and other things like that. So the data plane is where the container comes to life. In this presentation, we are going to focus exclusively on the data plane. We're going to mention EKS and ECS, which are the two orchestrators that you can use on the AWS cloud, and they represent the control plane in this context. But we will spend the majority of our time talking about the options that you have when you need to deploy containers on the AWS data plane. Why am I calling this the data plane optimization opportunity? Because at the core of this presentation is I want to challenge some of the assumption that you usually make when you deploy containers on AWS. And typically this assumption is to run containers, you need a cluster of Linux instances. And many of you as AWS users are doing that. However, what's happening is that fast forward to 2020, the data plane or the options that you have to make your container land on are exploding or blooming. So there is no longer one dimension, one assumption that you need a cluster of x86 Linux VMs where you need to run containers, but there is a number of different dimensions that we will try to cover for the remaining of this presentation. I like to say that the container data plane is becoming an ecosystem in itself. There are so many options available. And some of these dimensions allows you to create the stack that you need to solve your particular business problem. Some of these dimensions, but we'll go a little bit deeper as we go through the presentation, they may represent the location, the purchase options, the CPU architecture, and many other things. I like to describe this as a kind of a build-a-bear kind of approach, if you will. The other parallel that I usually use is that it's like if you have a number of colors in your palette and you need to paint a wall, right? You can pick the colors that you need to color and paint the wall the way that you exactly need to do that. So let's go a little bit deeper. What you see on this slide are these two rectangles that represent essentially the control plane and the data plane. As you can see in the control plane, you will see Amazon EKS and Amazon ECS. Those are the two orchestrators that you can use on the AWS cloud. They are both managed services. Amazon EKS is the implementation and the as a service version of Kubernetes, upstream Kubernetes. Amazon ECS is our homegrown orchestrator. We're not going to talk, as I said, in a lot of details about the orchestrator. What we're going to focus on is the bigger rectangle at the bottom of this slide. What I'm going to show you are the dimensions that we're going to touch upon. If you remember, I alluded to location, CPU architecture. These are the dimensions that allows you to pick exactly what you need to solve your technical or business problem. So let's start to go through some of these dimensions. So the first and most important dimension that we will touch upon is the technology dimension. This is where the core of the infrastructure is going to live. There are a number of other dimensions that we will touch upon, and these are the CPU architecture that you can use, the operating system that you may want or need to use, the location, as I alluded to, the extensions or infrastructure extensions, and the purchase options. If we put everything in a single slide, it would look like this. There are lots of options, right? Many of them are those that I have, those names that I have in my agenda. My job here in the next 20 minutes or so is to try to make sense of these names and trying to position these names so that you can connect the dots and you have more, you have a little bit of understanding of how you can map those to your needs. So let's start talking about and digging a little bit deeper into the technology aspect, which is pretty much EC2 versus Fargate. I'm not going to spend too much time talking about EC2 because I think that most of you understand EC2. EC2 is also the way that you would implement that assumption that we're trying to challenge with this presentation, if you remember. So the assumption is, in order to run containers, I need a cluster of Linux x86 VMs, and the VMs are EC2 instance in AWS parlance. So I'm not going to talk too much about that. I want to talk more about Fargate and what Fargate is. At the core, when I talk about Fargate, I usually say that cloud abstractions should not leak, yet they do. What do I mean by that? Think about what you need to do when you deploy an EC2 instance on AWS. When you deploy an EC2 instance or multiple EC2 instances on AWS, you're not asked control and have visibility in a cluster of physical servers so that you can start your EC2 instance. You just start an EC2 instance on an AWS region, in an AWS region, without worrying too much about the physicalities of that region. Similarly, if you want to trigger a Lambda function, you're not asked to monitor and to have full visibility and manageability of the stack that is underneath your Lambda function. Usually, when you run a Lambda function, you take your piece of code that you want to run as part of the Lambda function, you throw it into the Lambda service, and the Lambda service will take care of everything. And you don't see anything below that. However, if you think about how you usually launch containers on AWS or any other infrastructure, this is not true. And we are breaking that rule of abstractions should not leak. They leak because we're asking you to own a cluster of EC2 instances, even if you pick containers as your abstraction layer on AWS. I have a visual that tries to represent what I've been referring to. So what you see on this slide is the representation of these three different abstractions: the EC2 or VM abstraction, the container abstraction represented by EKS or ECS, and the function as a service abstraction represented by Lambda in this case. What you see in the middle of this screen is a line, it's a demarcation line between what you have to manage, what's abound, and what we, AWS, have to manage below the line. The reason for which I'm referring to this line as the theoretical abstraction demarcation is because based on what we have said so far, this is just theoretical. The practical demarcation line is different, and it looks something like this. So in order for you to be able to run containers, if that's the abstraction that you opted to use on AWS, you're asked to have a cluster of x86 Linux servers to run those containers on. So we're breaking that rule of abstractions should not leak. Enter Fargate. Fargate is the service that we introduced 3 years ago that allows us to fix that leakage. Fargate is the service that allows you to only think about containers, only think about your containerized application, and forget about what's underneath that line. So what's Fargate? Fargate is a fully managed serverless service to run containers. As I said before, with Fargate, you focus on your application. You don't focus on the cluster of EC2 instances that allows you to run your application. You just focus on how you containerize your application and how you deploy it on the AWS cloud. Fargate allows you to run containers without EC2 instances. As a matter of fact, when you deploy an ECS task or an EKS pod or Kubernetes pod on AWS on Fargate, you won't see any EC2 instance in your account. The way it works is that we will source an EC2 instance or micro VM from the fleet of the Fargate service, and we will run one-to-one a pod or a task on that instance. The other important thing is that even though we introduced Fargate initially with ECS and tightly tied to ECS, Fargate is now orchestrator agnostic. It works with both ECS and EKS. So regardless of the orchestrator that you're going to pick based on your business needs, ECS or EKS, you can still use Fargate. So this concludes this introduction about the technology choice between EC2 and Fargate. Let's jump very quickly into all these other 5 different dimensions that we alluded to. So we said that the technology dimension in the data plane is very important, and we spent lots of time talking about the Fargate and the difference between Fargate and EC2. We want now to cover all these other 5 dimensions very quickly. We're not going to go too deep in each of them, but I want to take this opportunity to talk about the options that you have for each of these dimensions. Let's start with the purchase option. So when you deploy your containers in the form of ECS task or EKS pod, you have to have an option that speaks to how am I going to pay for that container? Or if you use EC2, how am I going to pay for that EC2 instance that will run that container? So this speaks to the statement, I want to pay just about right. And what's right for me, for my use case, for my requirements. We have 3 options here. The first one is the classic cloud option, on demand. I want to pay for what I need when I need it. That's kind of the core of how purchasing resources on the cloud works. However, there may be some workloads that are more steady state, if you will. In that case, we do have purchase options for both Fargate and EC2 that speaks to being able to reserve capacity, or we are also calling these saving plans. Basically, the difference here is that you know upfront that you're going to use some amount of capacity on the AWS cloud. So what you do here is you commit to pay a minimum amount of money in return of a discount. So if you commit to use a certain amount of money, we give you in return more a discount. The third option, which is very cloudy, if you will, is spot. For those of you that don't know, the spot purchase option works like this. At any point in time in each of our regions, in each of our availability zones, we have spare capacity that we're not using for on-demand or reserve capacity. So what we do with that capacity is we offer it at a very deep discount, very, very deep discount, so that you can take advantage of that cheap capacity that is not being used by other users on the cloud. The contract or the virtual contract that you sign up for when you do this is that you know that AWS, if there is demand for on-demand purchase model or the reserve model, we will pull back that capacity from your account and we will give it to customers that are using the on-demand or the reserve model. So this is great for those workloads that tends to be either ephemeral or they could be interrupted and they could restart. They do not need to be completed in the least amount of time, for example, because it allows you to access and get access to a very, very deep discount with this limitation that I just alluded to. Let's move to what I refer to as the extensions or infrastructure extensions. So when you deploy containers, when you create your cluster and when you deploy your containers, it's very rare that you need to forget completely about the infrastructure. And by infrastructure, I mean things like, where am I going to ship my logs, for example? Or how can I connect to my data, to my volumes, for example, stuff like that. You need to be in an infrastructure context somehow. How do those containers know about the infrastructure that exists nearby? There are a number of options that you can use to configure the infrastructure based on your particular needs. One classic way to solve for this problem is to use daemon sets. Daemon set is a set of containers that gets deployed on each of the EC2 instances that comprise your cluster for infrastructure related things. Shipping logs is a good example, and I'm going to stick to it because it relates to a lot of things that each of us do on a daily basis. So the way that these daemon sets work is that for all containers running on a particular EC2 host, they grab the logs and they send the logs to an external entity. This external entity could be CloudWatch, it could be Elasticsearch, it could be anything. But these containers, these infrastructure extensions containers, run on each EC2 host. There are an alternative approach to this called the sidecar pattern, where you want to move that logic and that infrastructure extension closer to the pod or the task. What I described before with the daemon set is all of your cluster will behave the same way. However, you may need to change this behavior on a pod or a task basis. You may want a pod to log to CloudWatch and another pod to log to Elasticsearch, for example, or you may have different logging patterns. With the sidecar pattern, what you can do is you can put inside that pod or task, because it works for both EKS pod or ECS task. You could put an infrastructure containers called sidecar that will do that on a container basis or on a pod or task basis. There is one last pattern that we will briefly touch upon, which is called the hidecar. Think about that. When I said before, Fargate will allow you to remove a lot of the infrastructure related work that you need to do, so removing the undifferentiated heavy lifting, as we call it. You may even, give to AWS the management of some of these extensions, right? So these extensions cannot be deployed on EC2 instances at that point, because there are no EC2 instances that you can deploy to in Fargate, because they're completely hidden. And so we provide those functionalities as part of the managed infrastructure. That's how we, and why we call them hidecars. A good example of these are the CSI EFS driver or the Fluent bit router with Firelance when you use EKS and Fargate. If you use EKS Fargate and you need to connect to EFS storage, or you need to send logs through the Firelance router to Elasticsearch or CloudWatch, you don't need to have those extensions. We will provide that as a service for you as part of the managed infrastructure that Fargate is. Let's move to the location. Very important. So this speaks to the desire to be able to run my containers when I need them. So think about this. Obviously, when we talk about the cloud, you get to deploy your containers inside the AWS region or a specific availability zone inside that AWS region. And that is the default, right? So I want to take the advantage of all cloud benefits, right? Because you're deploying into the region with the elasticity that the region allows you to do. But over the years, we have introduced more flexibility in terms of how you can deploy your containers and where you can deploy your containers. I'm not going to spend too much time on local zone and wavelength, but those are two services that we introduced this year that will allow you to deploy your containerized application, both EKS or ECS, in AWS managed properties that are, for example, closer to you, so you can appreciate lower latency of accessing those services, or they are deployed in conjunction with our network partners to take full advantage of the new 5G networks. The last option that I want to talk about, which is very important, is AWS Outpost. So for those of you that haven't been following the evolution of Outpost. Outpost is basically a piece of the AWS infrastructure, literally a piece of the AWS infrastructure that instead of shipping into a region or an availability zone, we take it and we ship it on-prem in your data center. So basically, AWS Outpost allows you to use the fully compliant AWS cloud operational model, but on-prem. The way it works is that we ship gears into your data center instead of shipping them to an availability zone. There is a setup procedure that will connect that AWS Outpost to the region, so it becomes part of the region, so that when you deploy your containerized application through EKS or ECS, you have an option of deploying that capacity, you have an option to deploy those containers on capacity that exists inside your data center. The key thing here is that that capacity is literally it's organic part of the region. It behaves like any other gears in the region behaves. It's a part of that infrastructure. Let's move to the operating system. Again, this is another important dimension. And here, the tenet is I want to use the operating system that's right for me. I want to use an operating system that I have to use or I want to use. So the typical example here is a general purpose Linux. It could be Amazon Linux 2, it could be Ubuntu, it could be Red Hat Enterprise Linux. It depends on where I'm coming from. It depends if I have particular technical or commercial requirements. We give you the option of being able to do that. The other thing, and this is another name that I showed on the agenda slide, is BattleRocket. For those of you that haven't been following the evolution of what we have been doing in this space, BattleRocket is an open source Linux distribution that is purposely built to run containers. So this is not a general purpose OS like those that you see on the slide at the top, but this is an OS that we built and we open source that has been purposely built to run containers. Last but not least, lots of people are running legacy workloads on Windows. And Windows has introduced support for containers a few years ago. And there are lots of people that are taking their Windows application, they're containerizing them. We want them to find a good home at AWS. So our data plane supports Windows. Last but not least, something that our customers are very excited about because of the possibility that it opens is a choice of CPU architecture. Again, this is all about I want to use the right CPU options to solve my problems. Remember the assumption that we talked about at the very beginning, I need a bunch of Linux VMs in a cluster to run my containers. x86 is kind of the default there, right? Typically, you would run those containers on an x86 entity, right? So this is, I need good price performance option. However, we do have also options for GPUs. So lots of our EC2 instances, for example, they do provide GPU capabilities for those containerized workloads that needs to access GPUs. Think about machine learning and things like that. Last but not least, ARM. ARM, or the Graviton 2 processor that we just launched in the new Graviton-based instances, is providing lots of customers with great advantages in terms of price performance. With Graviton 2, you can pay less and get more performance out. There is maybe a tax that you need to pay in terms of more work that you need to do to recompile your application to be able to run on an ARM processor rather than a traditional x86 processor. But once you are in a position to be able to recompile your application, you get access to that more performance at less price. The other thing that is important to know is that a lot of our services, managed services like Elasticsearch, for example, or RDS and many more to come, they're migrating or they're giving the option themselves to use the ARM version of the infrastructure underneath them to allow for a more cost-effective service. So we went through all of these options. How do they tie together? So these are the 5 dimensions that we talk about, right? So the purchase option, the infrastructure extension, the location, the operating system, and the CPU architecture. How do I mix and match them? They are a function of 2 things, or what you can use is a function of 2 things. The first thing that they're a function of is the orchestrator that you're using. If you pick an orchestrator, you may be limited to use more or less of these options. The second thing that they're a function of is the technology that you want to use in the data plane. So depending on whether you want to use EC2 or Fargate, you may get access or not to some of these options for how you build your own data plane. Let's go very quickly through like a recap or an example of what this looks like. So EKS, EC2, if you end up using EKS and EC2, those are all the options that you have available. As you can see, the only option that you don't have available is the sidecar, because it doesn't make any sense, right? You're using EC2, you're managing that cluster at the end of the day, so there isn't much that you can hide. If you use Amazon EKS with Fargate, obviously you get access to sidecars, so you're giving us more stuff to work on, but many of these other options are not available as of today when you use Fargate. For example, if you want to use ARM as a CPU architecture, that's not yet available on Fargate. There are lots of customers that are asking us to support that with Fargate, but as of today, it's not available, like many other things. Similar picture for ECS and EC2. As you can see, similar option that you had with EKS. And similarly, some of the limitations with ECS and Fargate that we have shown with EKS and Fargate. So depending on the orchestrator that you pick and the technology that you choose for your data plane, you may get access or not to some of those options. It's important to understand that these, and I wanted to call it out as of December 2020, these are moving targets. As we move forward, we will fix these holes and we will provide more options for Fargate, for example. So in conclusions, what we have been doing with this presentation is we have explored the data plane options that goes beyond the usual, I need a cluster of x86 Linux instances to run my containers. I hope that you appreciate a little bit of a challenge to go beyond that part. What I tried to do was to try to show you how you can match your business requirement with some of the options that we offer. So for example, you may want to over-index your deployment on performance or availability or cost. And depending on what you want to over-index it on, you may want to choose and pick the options that make more sense for you. The last thing is we want to hear what options you want us to deliver and what options you want to work with other options. So we are all ears to hear what the combinations that you need are. These are some of the call to action and links that I wanted to show you. Please feel free to dive deep. Thank you very much for sticking with me through this session. This is my Twitter handle. Reach out to me if you have any question, and don't forget to complete the session survey. Thank you very much.